So here we are with the first example, well it's example 10 but it's on vertical motion under gravity, and we've got a number of new things to think about here particularly. So first of all, let's read the question. As usual, lift out the key information. A book falls off the top shelf of a bookcase. The shelf is 1.4 metres above a wooden floor. Find the time taken the book takes to reach the floor. So the time taken and the speed with which the book strikes the floor. So we've got our book, we've got our floor. This distance here we're given as 1.4 metres. Okay, and really what I'm saying to you at the start is draw or sketch the info from the question. So that's what we're told, but we can add a number of other things to that. So what else do we want to know? Well, the first thing we can recognise here that it's a constant acceleration, context, and we're going to want to define a positive direction as well as an origin or a starting point of zero. So usually, not always, but usually the best thing to do is to take your origin as the starting point. Yeah, so the origin is the starting point. Origin is starting point. And the positive as the initial direction of motion from here. And the positive direction as the initial direction of motion from this point. The key thing is to keep consistent with your positive all the way. So the direction of increasing x tends to be the positive direction, or should be the positive direction. So here we are going to take down as positive. So the down is going to be positive. Okay. Now, what else can we add to this diagram? Okay, go back, read the question. A book falls off the top shelf of a bookcase. If it's falling, what can you tell me about its initial speed downwards? Well, hopefully you've picked out u equals 0, and I'm going to use our standard SUVAT letters, u. Okay, so it starts with initial speed u. We want for the time it takes to reach the floor. So down here we could have t is equal to capital T. What happens as the book falls? Well, it's going to accelerate due to gravity, g. And for mechanics, we let g equal 9.8 meters per second squared, unless otherwise stated in the question. Just occasionally they'll say leave g in the answer, or they'll say let g equal 10. Okay, so just look carefully at the questions to see what they've asked you to do, but 9.8 is the usual standard in exams. Okay, so constant acceleration. U is equal to 0, A is equal to g, T is equal to capital T, and S equals 1.4. So look at those letters, S, U, A and T, and hopefully you've learnt the constant acceleration equations so you know what we're going to do next. State the right equation, we hope, substitute in the values, and then solve it, stroke calculate it, stroke work it out, just depending on the question. So S equals UT, plus a half at squared. Substitute in 1.4 is equal to u, which is 0. And we've said let t equal capital T when it hits the ground, plus a half gt squared. And now we solve it to find t. So, usual approach, equation with a fraction multiplied by the denominator. So we've got 2.8 is equal to gt squared, multiplying through by 2, which is the denominator, multiplied by denominator, which happens to be 2 on this occasion. And now we can divide by g and square root. So t is equal to 2.8 over g square rooted. I would probably rather write the 2.8 as 14 over 5. So we get 14 over 5g square rooted, and that's again used this idea that a over b over c equals a over bc. That little idea comes in quite a lot, and I've let 2.8 equal 14 over 5 to do that. Now 5g is one of those things that comes up quite a lot, particularly in these kind of contexts. So 5g is equal to 49, which is very nice here because that's got a common factor with the 14. So we've got the square root of 14 over 49. We can divide top and bottom by 7, so we get the square root of 2/7 of a second to reach the ground. Okay, I hope that's clear. That's part A. Now we can go back and do B. Find the speed with which the book strikes the ground. So B, well, the speed it strikes the ground, we would call that the speed at the end. Right? And sadly, many students think that the answer to this is 0, because after it's hit the ground, it's got a speed of 0, because it doesn't go any further, and it's stationary. But we want to know the speed at which it reaches the ground. And obviously it must be moving in order to reach the ground. Yeah? So we want the speed v with which it hits the ground. The other thing with these questions is that it's best to go back and use the values that we have not calculated. So information from the question. So here, that would be the the U, the A and the S value, not using the T because that's a calculated value. You can't always do that, but when you can, it's best to use the information in the question. So U is still 0, A is still G, S is still 1.4 or 7 over 5, if we'd rather write it like that, and we want V. So we go into our state sub-solve phase. Yeah, so state sub-solve. We look at the letters U, A, S and V. And I hope you can now recall the right equation for that, because you've learnt them. V squared equals U squared plus 2AS is the one without T in. So we now substitute in V squared equals 0 squared plus 2G 7 over 5. So V squared equals 14G over 5. If we square root, we get V equals the square root of 14G over 5. and you could tap that in a calculator to get a value, or that would do, meters per second. You can just tap that in if you want to. 2.8, roughly 28, square root of 28 is going to be 5.2-ish, 5.3-ish. Okay.